66 million years ago, on a morning that seemed like any other, the sun rose over a world that belonged to giants. In what we now call the Yucatan Peninsula, a young Tyrannosaurus rex stirred from sleep, unaware that this would be the last sunrise of an era. The air was thick and warm, filled with the calls of creatures that had never known winter, never known fear of the sky. But 66 million miles away, something was coming, a mountain of rock and ice, 6 miles wide, hurtling through the vacuum of space. In just a few hours, it would rewrite the story of life on Earth. This is the story of the worst day in the history of our planet. The late Cretaceous was a paradise of extremes, forests of flowering plants, a relatively new invention stretched across continents that would be unrecognizable to us today. The Atlantic Ocean was narrower, India was an island, and dinosaurs were everywhere. In the shallow seas that covered much of North America, massive mosasaurs, 50-foot marine reptiles hunted schools of fish. Tyrannosaurs with wingspans wider than fighter jets soared on thermal currents. And on land, the dinosaurs had diversified into thousands of species, from the armored Ankylosaurus to the intelligent pack-hunting velociraptors. They had survived ice ages, volcanic eruptions, and countless other extinctions. They were, by every measure, the most successful large animals ever to walk the Earth. But success is not the same as invincibility. The asteroid that would end their world was born in the chaos between Mars and Jupiter, in a belt of millions of rocky fragments left over from the formation of our solar system. For billions of years it orbited peacefully. Then, perhaps a million years before impact, a collision sent it spinning inward, toward the Sun, toward us. As it crossed Mars's orbit, then Earth's orbit on previous passes, it was just another near miss, one of thousands that happen every year. But on this particular orbit, the mathematics of gravity aligned with terrible precision. Earth would be in exactly the wrong place, at exactly the wrong time. The asteroid entered Earth's atmosphere at an angle, glowing white-hot from friction, crossing the sky like a second sun. From the ground, any creature looking up would have seen it for only 2 or 3 seconds before impact. Not enough time to run, not enough time to hide. At 10:47 a.m. local time, the asteroid struck the shallow sea off the coast of what is now Mexico. In the first second, it punched through the atmosphere, the ocean, and 6 miles into the Earth's crust, releasing the energy of 10 billion Hiroshima bombs. The impact vaporized the asteroid instantly, along with thousands of cubic miles of rock, creating a fireball that reached the edge of space. A crater 20 miles deep and 120 miles wide formed in seconds. The seafloor became a mushroom cloud. Within 2 minutes, a wall of rock and water, a tsunami 300 feet high, was racing outward in all directions at the speed of sound. Earthquakes measuring magnitude 11 off our current scale shattered the continental plates. In the forests of North America 2,000 miles away, dinosaurs felt the ground begin to shake. Trees swayed, birds took flight, but this was just the beginning. The real killer was still climbing into the sky. The blast wave from the impact moved outward like an invisible wall of compressed air, flattening everything within 1,000 miles. Forests were stripped to splinters, creatures were thrown like toys. The sound, a roar beyond anything in human experience, ruptured eardrums and burst lungs. But most dinosaurs weren't close enough to die from the blast. They died from what came next. The impact had ejected trillions of tons of vaporized rock into the upper atmosphere. Within minutes, this material began to rain back down, not as solid rocks but as tiny spherules of molten glass, still glowing red-hot. Imagine a global hailstorm of lava. The air temperature across the entire planet began to rise. Within an hour, it reached 300 degrees Fahrenheit in some regions. Forests spontaneously ignited. Animals that had survived the initial shockwave now faced an oven. Those that could burrow underground had a chance. Those that couldn't, the large dinosaurs, the flying reptiles, had nowhere to go. By late afternoon, half the planet was on fire. Wildfires, ignited by the heat pulse and falling ejecta, merged into continental-scale infernos. The smoke rose into the stratosphere, joining the dust and ash already there. In North America, a triceratops herd stampeded through a burning forest, their calls drowned out by the roar of flames. Some made it to rivers, only to find the water boiling from the heat. In what is now Montana, a fossilized site called Tanis would later preserve this moment in exquisite detail. Fish with impact spherules in their gills, trees buried mid-burn, creatures caught in the act of dying. The fossil record shows no sign of a gradual decline. One layer of rock contains a thriving ecosystem. The layer above it, separated by just a few centimeters, contains almost nothing. The boundary between them marks the exact moment when the old world ended and the new one began. As the sun set on the last day of the dinosaurs, the sky was no longer blue, It was a churning mass of black and red smoke, ash and vaporized rock blotting out the stars. The few creatures that had survived the heat, the fires and the tsunamis now faced a new threat: darkness. The impact had ejected so much material into the atmosphere that sunlight could no longer reach the surface. Temperatures, which had spiked to lethal highs, now began to plummet. Within days, it would be below freezing across most of the planet. Within weeks, it would stay that way. Photosynthesis stopped, plants died, herbivores starved, carnivores with nothing left to hunt turned on each other and then starved too. The darkness would last for months, possibly years. Scientists call this impact winter. It was a nuclear winter without the war, an apocalypse without warning. But not everything died. In the ruins of the old world, small creatures clung to life. Mammals, most no larger than rats, survived in burrows, feeding on seeds, insects and carrion. Birds, the direct descendants of dinosaurs, survived because they were small, adaptable, and could migrate. Crocodiles and turtles, with slow metabolisms and the ability to go months without food, waited out the darkness in rivers and swamps. These survivors had several things in common. They were small, they didn't need much food, and they could shelter from the extreme conditions. The great dinosaurs had none of these advantages. A Tyrannosaurus rex needed hundreds of pounds of meat every week. When the herbivores died, the carnivores followed. Within a year, possibly less, every non-avian dinosaur on Earth was gone. An entire dynasty, 165 million years in the making, erased in a geological instant. Weeks after the impact, the Earth was unrecognizable. The skies were still dark. Acid rain, created from vaporized sulfur in the impact rock, had poisoned the oceans, killing 75% of marine species. The once lush forests were graveyards of charred stumps. Layers of ash covered everything like gray snow. In this wasteland, the survivors emerged. A small mammal, perhaps an ancestor of primates, scurried across the ash, searching for food. It found the skeleton of a triceratops, picked clean by scavengers, now half buried. This mammal had lived in the shadow of dinosaurs its entire life, never growing larger than a shrew, always prey, never predator. But now the giants were gone. The world was empty. And for the first time in 165 million years, mammals had room to evolve. It took tens of thousands of years for the skies to clear, for the ash to settle, for the sun to return. When it did, life began again, but it was different. Ferns were the first plants to return, their spores having survived in the soil. Insects followed, then small reptiles, then birds. The mammals, no longer confined to the night shift, began to diversify. Within a million years, a blink in geological time, they had evolved into dozens of new forms. Some took to the trees, others took to the water. Some grew larger, filling the ecological roles left vacant by the dinosaurs. In 10 million years, there would be mammals as large as elephants. In 30 million years, whales would rule the oceans. And in 65 million years, one lineage of mammals would evolve large brains, opposable thumbs, and the ability to ask questions about the past. That lineage was us. For most of human history, we had no idea this had happened. Dinosaur fossils were mistaken for dragons, giants, or mythical beasts. It wasn't until 1980 that a physicist named Luis Alvarez and his son Walter, a geologist, made a startling discovery. They found a thin layer of clay and rock formations around the world, all dating to exactly 66 million years ago. This layer contained iridium, a metal rare on Earth but common in asteroids, at concentrations hundreds of times higher than normal. They proposed the unthinkable. A massive asteroid impact had caused a mass extinction. The scientific community was skeptical. Where was the crater? Then in 1991, geologists confirmed it. Buried under the Yucatan Peninsula, hidden beneath jungle and ocean, was the Chicxulub crater, the scar left by the asteroid that ended the age of dinosaurs. It was one of the most important discoveries in the history of science, confirming that our planet's history has been shaped not just by gradual change, but by sudden catastrophic events. The story of the dinosaurs is a reminder that dominance is not permanent. For 165 million years, they were the undisputed rulers of the Earth, longer than mammals have existed, longer than flowering plants, longer than the Atlantic Ocean. They survived ice ages, volcanic eruptions and climate shifts, but they couldn't survive a random piece of rock from space. Today we are the dominant species. We've built civilizations, split the atom, and walked on the moon. But we're just as vulnerable. Right now, astronomers track thousands of near-Earth asteroids, looking for the next potential impact. Most will miss. But statistically, eventually, one won't. The question is not if another asteroid will strike Earth, but when and whether we'll be ready. The dinosaurs had no warning, no technology, no chance. We do. That might make all the difference. On a quiet morning in Montana, a paleontologist carefully brushes dust from a fossilized bone, a Triceratops horn, perfectly preserved in the rock. It's been here for 66 million years, waiting to tell its story. The dinosaurs are gone, but they're not forgotten. They live on in museums, in our imaginations, and in every bird that sings at dawn. They remind us that life is resilient but not invincible, that the universe is indifferent to our existence, and that every day we wake up to a sunrise is a gift. 66 million years ago, the world ended and began again. The dinosaurs had their time, now we have ours. The question is, what will we do with it? The asteroid is still out there, somewhere in the darkness between worlds, and the clock is ticking.